You ready?
Ready.
Boom.
Okay. I'm here to talk to you about the search for extraterrestrial life, pause, in our solar system. So why the pause? Because usually when you think about the search for extraterrestrial life, you think about intelligent life. That's been very popularized, and it's ongoing too. And here's Contact, the movie Contact, Jodie Foster, and that was the theme behind that movie. But written by Carl Sagan, by the way, that book. It's a great book. But life in our solar system, or we're looking for the building blocks of life, and life on Earth began. You see a lot of life here, but life began in the oceans, and it started. Well, we're not really quite sure how it started, but basic building blocks at first. So the solar system might have those basic building blocks. Okay, and one place to look is Mars. And when people first looked at Mars in the 17th century with telescopes, they saw the polar ice caps. So they thought water, the Earth has polar ice caps. Maybe that's there's water there. Also, in the 19th century, they saw what appeared to be canals, and that led to people speculating about civilizations. And actually, that was the impetus for War of the Worlds. 19th century, it really ballooned into all of these theories about life on Mars. But as it turns out, really, Mars is barren. I shouldn't say lifeless, but there's no water. But now we know that there actually were oceans on Mars, rivers and oceans. And the water left Mars because of the loss of the atmosphere. But maybe life still exists below the surface, or fossilized life too. And so this is a Viking. Viking went to Mars, scooped up some of the soil, and looked for biosignatures, signs of life. It missed Carl Sagan, by the way. We've also sent rovers to Mars, and there's a bunch of rovers there now, but still, we haven't found any clear indication of life. We missed all these people, though. I don't know how they did that. But the most recent, really exciting discoveries have been these plumes of salty water coming off. Here's Europa. It's a moon of Jupiter. And the Hubble Space Telescope took these pictures. This picture was taken from a satellite called Cassini, and it's been orbiting Saturn, and it also saw these plumes. And they theorized that these are generated from deep ocean thermal vents, just like here on Earth. Now, these thermal vents, this is one on Earth. This is where we think life actually started on Earth. And without sunlight, but through chemical processes down there. And here's a sort of an artist's rendition of what we think might be happening on Enceladus, where you have this ocean, you have this icy crust, but then you have these thermal vents generating all this heat, and actually this ice gets projected out into space, and that's where we come in with the Enceladus Organic Analyzer. We want to get some of that ice, put it in here, and basically do a bunch of interesting things that I don't really know that much about yet. And here's another diagram that shows you what's going on. It's basically a very small chemistry set is what it boils down to. Very sophisticated chemistry set, where you just mix what you found with some reagents and possibly, and then analyze what you've found and see if there's some precursors or building blocks of life. They call them biosignatures, and they still have yet to find these on Mars, and they're still looking. And they're organic molecules, and organic molecules are molecules that have carbon in them. And this is what we're basically looking for. If we can find those, well then life possibly exists. We have to get to Enceladus, and so we want to hitch a ride with a spacecraft that's going to fly through the plume and collect some water and get it to our instrument, which will be on there, and then we'll analyze it, we'll discover life, and we'll win the Nobel Prize. I mean, I really think this is going to happen. I think life is there. And then, but the really most interesting thing, I think, is this: if we're successful, then we're going to go back with much more energy and get something through the ice and into the ocean where we can basically cruise around and look at these thermal vents just like here, and more advanced, and see more developed life forms down there. So that's my talk. So I guess it's Q&A? Q&A.
So first of all, I didn't know there were multiple moons that had an underwater ocean sort of system. So thank you for letting me know that. There is one of the pictures about from Euclid. If you can go back.
One more.
That one. Is that an actual picture or an artist?
You know, it is a picture, but I think somebody like
What is
that looks
That's
like
what
it's
took the picture or something?
No, that's just somebody must have somebody must have added
Oh,
that.
I see.
Yeah.
I was.
They must have-
intrigued
they
if
must have added
was
that.
another pro.
Yeah.
Which seems.
It was
Selfie bug.
there was a spacecraft launched a long time ago called Cassini, and it's been spending years orbiting Saturn, and it just sort of gave its last hurrah. It was going to run out of fuel, and it was probably going to enter Saturn, and so they swung it by the moons, Enceladus being one, to get some closer looks, and that's when they discovered these plumes. Actually, these plumes feed into the rings of Saturn.
Huh.
So they help form the rings. Yeah.
What is it that is giving them that much thermal energy that they can essentially a geyser can break
Yeah.
orbit?
Well, they call it tidal forces, where it's just like here. There's as you're orbiting. These moons are orbiting Saturn. Saturn is pulling and pushing. Other moons are pulling and pushing, and so you generate these tidal forces generate the energy. Also, just that orbital dynamics are sort of the planet's sort of being crushed and pooled, and so the energy generated at the core will move out and heat up and break through into these vents. Question? Right.
There was a slide right before the War of the Worlds.
Yeah.
Slide at the beginning. That was, yeah. What is that?
So, in the 19th century, a famous astronomer. Obviously, there were a few astronomers who were looking at Mars, and they saw what they thought were canals, and they drew these pictures from what they saw through their telescopes. And so basically what they were doing is they were connecting geological features, and to them it looks, and so they sort of extrapolated, and they're like, oh my God, canals. Well, we built canals, so there must be civilizations there. Edgar Rice Burroughs,
It's the Barsoom series.
this generated all kinds. I mean, even artists, poets, writers. It sort of found its way into a lot of work. Yeah, but as the telescopes got better, more sophisticated, and you could actually train scientific instruments, you could collect the light coming from Mars and look at it a little bit more scientifically. They're like, no, there's no water there. There's not even an atmosphere. So, yeah.
So when the chemistry set you're sending up finds biomarkers, what would be the next step in confirming that there's life? Like,
You'd have to get down there. Like that last picture I showed was actually, you'd have to get into the ocean.
so, but would you need like visual confirmation or like?
Well, that's a good question.
analytical
You'd probably have some more involved. You could do some more involved chemical. I'm not the chemist here, but yeah, they could collect and do some more. It would have to be like a sort of a bigger experiment, I think, a more involved experiment. But visually would be more appealing,
Yeah.
I think. Anyway, it's more sexy, too,
Yeah.
in some ways. But I'm sure you're right. That's what they'll probably do. Is they're just going to have a smarter, a more advanced experiment that can really pick up on a larger molecule, perhaps, or yeah, or maybe even see some smaller microbial life. You know. Yes.
After the question of is there life on other planets and answers, what's the next question after that?
Well, I mean, the question. I mean, I think the real question is how did it start? Because we still don't know how it started here. Basically, we had inanimate material, and then it turned into life. It went to, so abiogenesis it's called. Something went from inanimate to animate, and so I think if we discover life there, it'll help us because we could see life. We could see like what life was like 1 billion years ago on this planet, right? And that would help us figure out, oh, well, maybe it started this way.
Assuming that it is on the same trajectory.
Yeah. Yeah.
Two-part question. When did we first discover these oceans on the moons of the gas giants? And then second, how much do we really know about it? Because, like, we have the, Mars, for example. Landing a spacecraft on Mars is tremendously complicated, but we know what the surface looks like. And you're looking at a mission that follows up this other one trying to go under the ocean. It sounds crazy.
No, the other way. Keep going. Oh, I'm sorry. Yeah, the other way.
But it sounds crazy. I'm just like, how are we going to plan that when we don't know what's underneath?
Yeah, right. Well, they're able to, when they analyze the plume, the instruments they point at it can tell them the salt content, some of the materials, the energy, and then I think some of the other analysis they can sort of come up with thickness. How the moon moves can tell you, oh, there's actually water. One thing about Enceladus is that it wobbles. Yeah, so like when something has water in it and it's moving. So they're using all kinds of information. This is the Hubble Space Telescope. It's got, when it takes the light in an image, they can like break it down into all kinds of interesting information. And the same with Cassini. It trained these instruments that were used to looking at other things, but could still be used to figure stuff out, content-wise, like what. But yeah, I mean, they're still a long way. But I mean, they're really confident. I think that that is salty brine water. I mean, almost like the oceans here, and they're pretty confident that there is a liquid ocean. This it's interesting. It's a small moon. This diameter is the length of Great Britain. Yeah, it's small. Europe is much bigger. It's like, I mean, it's half the size of Earth, I think. Yeah.
Are those dates the date that it was first discovered?
Yeah.
Okay, so like 2014 is when we first figured out there was.
Yeah. Yep. Yes.
I was wondering, what's the timeline? Like, when do you think we'll first? You might have mentioned.
Well, there's actually we don't have a ride yet. Like we're working on we're working on developing the instrument, and the way NASA works is it's kind of Byzantine. Like they'll fund you to come up with a concept to fund your concept, and it looks like it works. Okay, now we got to find a mission, and missions usually are taking instruments from all over different universities to do different things, right? So it's a really big endeavor. This going out there is a big endeavor. There actually is one going to Europa right now. It's called the Europa Clipper, and
You missed that one.
we did. I was just asking about. I'm like, why didn't you guys get on Europa Clipper? And it was like we just weren't ready. They just weren't ready, and they might discover life before we do. So, but that's okay. I think we had a question over here.
I'm assuming most of this, like the biomarkers and stuff, is for carbon-based life form?
Yeah.
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 What is the hardest technical hurdle on the probe? What is the hardest technical hurdle on the probe that you're doing?
The hardest technical hurdle?
Yeah.
Geez, right now it's just making it work.
Pretty big one.
It's this very small. It's you just get. I'm not exactly sure. I mean, I'm sort of one step removed from it, where I build all the GSC that is used to sort of control it. So it is this thing which, takes it. Describe it. It's a little chemistry set, and it's got little reservoirs, and you get to collect the material in the ice, and you put it somewhere, and then you take in some reagent. And you sort of mix, and you pump it around, and you pump it over here, and you store it for a while, and then you take it, you move it through these little tiny. We're the only ones who actually do this. That's why this professor at UC Berkeley has sort of developed this technique, and it's very. I should say it's like sort of benign to the sample. It's easier on the sample when you want to look at something. Whereas a lot of these searches for life, like the Mars missions, for instance, they crush the material and they blast it with a laser. I forget what that's called, that technique, but it really is a harsh technique for looking for life. So it's just actually it's getting this little pumping system to work, because we got to pump water. The system uses water. Water gets pumped around, and you use liquid nitrogen. You use nitrogen to sort of as a sort of a pressure source, and you got to do that in 0G. So it's just, got these 49 little pneumatic pumps that we're trying to get all the work, and they're sticking right now.
Alright, thank you. One more? Last one?
Yeah, I saw in the news, I think this week, that there was some methane outgassing detected on Mars.
Right.
What was that all about?
Well, methane, sign of life. Cows farting.
Right.
It's the way it's been described to me, and I was like, the search for life in our solar system, that is one of sort of that's a biomarker, and but I just had to edit out. I was looking at how much I could present, but yeah, that's they've saw Mars. They've seen it somewhere else too. So methane, right? Methane occurs naturally, but the way it occurs naturally, the cycle of naturally occurring methane looks one way, but if you have life farting out methane, that is the periodicity of that is different. So you could be like, whoa, that's unusual. A naturally occurring methane doesn't occur like that, right? So they're not sure. They're not sure right now about that.
All right.
Thanks.